The final topic of this chapter is life cycle costs. So, if you remember, we have discussed what we mean by life cycle and life cycle costs earlier in a brief way. So, let's recall life cycle. So, life cycle of a project of a product means it starts from the idea stage and it ends with the demise of the product. Let's say you are planning to start a business or a project or launch a product. So, how you will start? First of all, you will start with an idea. Then you will search for some background information to convert this idea into a reality. You will prepare a prototype. Once the prototype is prepared, it will be tested. After testing, it will be launched commercially. So at start, once the product is launched in the market, it will be at introduction stage. Sales will be less at this stage, expenses will be higher, and income will be less. And once the time will pass and the customer will start using your product, sales will increase, it will come into into growth stage. Once the sale started to increase, then the point will come when the sales will go at peak, and this stage will be known as maturity. And after that, the sales will started to decrease, and this stage will be known as decline stage. And finally, at this stage, the other alternative will be available in the market, competitors will come in the market, so the demand of your product will decrease due to the availability of other alternatives. And finally, the product will go out of the market. I mean, sales will come to lowest again. So this stage is known as demise. So life cycle, all the time from the initial conception of an idea to the death of a product or process, is known as life cycle of a project or product. Life cycle costs are sum or total of all the costs incurred during the life cycle. Means at idea stage, introduction stage, growth stage, maturity stage, decline and demise stage. The cost incurred at each stage will be added together and the total cost will be known as life cycle cost. And life cycle costing, designing a product with an understanding of all the costs associated with the product during its life cycles. Means you need to develop or design a product by understanding the costs, estimates associated with each stage of the life cycle of that product. So this is known as life cycle costing. Now, life cycle cost analysis. Life cycle cost analysis use annual worth or present worth methods to evaluate cost estimates for the entire life cycle of one or more projects. Means you can evaluate one or more than one project by using life cycle cost analysis. Estimates will cover the entire lifespan from the early conceptual stage through the design and development stage, through the operating stage, and even the phase out and disposal stages. Both direct and indirect costs are associated or included to the extent possible. In differences in revenues and savings estimates between alternatives are included. Now here two new terms are being used, direct and indirect costs. By direct costs mean direct costs are those costs that can be directly identified with the product, and indirect costs are those costs that cannot be directly identified with the product. For example, if you're using a cell phone, it it has a screen, so the cost of screen can be identified directly with it. So the raw material being used to design a product is known as direct cost. On the other hand side, there are some other indirect costs, such as the salaries of employee who was working on the plant, rent of the building, electricity bills. So these are also the costs, but cannot be directly identified with the product. But these costs have been incurred to prepare the product, to make it available in the market, to sell it. So these costs are known as indirect costs. So direct costs refers to the material, human labor, equipment, supplies, and other costs directly related to a product, process, or system. Indirect costs refers to the taxes, management salaries, legal expenses, warranty, quality, human resources, insurance, software, or procurement expenses. These are few examples of direct and indirect costs. Now the next thing is life cycle cost analysis. Use annual worth or present worth methods to evaluate cost estimates for the entire life cycle of one or more projects. Most commonly, the least common, most commonly, the life cycle cost analysis includes costs, cost alternatives, and the annual worth method is used for the analysis, especially if only one alternative is evaluated. If there are expected revenue or other benefit differences between alternatives, a present worth analysis is recommended. So if you have to compare only cost alternatives, then you can use annual worth method. And if you have to compare life cycle cost analysis involving revenue alternatives, then in that case present worth is preferred or recommended. Public sector projects are usually evaluated using a benefit cost analysis that we'll cover in chapter 9 rather than life cycle cost analysis, because estimates to the citizenry are difficult to make with much accuracy. That's why we'll use benefit cost analysis rather than life cycle cost analysis, and we'll discuss how to how to perform benefit cost analysis in chapter 9 in coming weeks. Now, what are the applications of life cycle cost analysis? LCC methods applications are lifespan analysis for military and commercial aircraft, new manufacturing plants, new automobile models, new and expanded product lines, and government systems at federal and state levels. In simple words, you can apply life cycle cost analysis for any kind of organization who perform their tasks in several steps. For example, introduction stage, growth stage, maturity stage, then decline stage, where they can segregate their operations in different steps. So in that case, any company can apply life cycle cost analysis. For example, the US Department of Defense requires that a government contractor include an LCC budget and analysis in the originating proposal for most projects. When to use life cycle cost analysis? Life cycle costs analysis is more effective when significant percentage of the lifespan costs relative to the initial investment is expected to be spent on operating, maintenance, and similar costs once the system is operational. In simple words, LCC is preferred when the significant amount is being spent on maintenance and operating expenditures in as compared to the initial investment. Example, here are a few examples. First example is the evaluation of two equipment purchase alternatives with expected useful lives of 5 years and maintenance and operating costs of 5% to 10% of the initial investment. So here, if we see the annual operating and maintenance expenditures are between 5 to 10% per annum of the total initial investment. So which is not a significant amount as compared to the initial investment. So in that case, life cycle cost analysis is not required. So here is another example. ExxonMobil wants to evaluate the design, construction, operation, and support of a new type and style of tanker that can transport oil over long distances of ocean. If the initial costs are in the hundred millions, with support and operating costs ranging from 25 to 35% of this amount over a 25-year life. Now, if we see the operating and maintenance expenditures are between 25 to 35% of initial investment. So this is a significant amount. In that case, we will use life cycle cost analysis to compare this project. How to perform life cycle cost analysis? First of all, to perform LCC analysis, one need to identify each stage of product, system, or an alternative during entire life. Second, however, at this stage, we will be given with all stages of life cycle and we will be asked to calculate LCC. If not given, then we need to identify each stage of product, system, or alternative during entire life. If given, we do not need to identify such stages and perform calculations on the basis of given information. We then follow the following steps. First of all, we'll calculate the present worth by phase and stage. Then we'll add all present worth values of each stage. Then using present worth calculated in step 2, we'll calculate the annual worth over entire life cycle of the alternative. So keep in mind, first of all, we have to calculate present worth by phase and stage. Then we have to add all present worth values of each stage, and then we have to convert these present worth values into annual worth value over entire life cycle of the alternative. Here is an example how to perform life cycle cost analysis. A medium-sized municipality plans to develop a software system to assist in product selection during the next 10 years. A life cycle cost approach has been used to categorize costs into development, programming, operating, and support costs for each alternatives. So if you see, we have already defined 4 categories: development, programming, operating, and support costs. Now we do not need to identify these categories. We just need to perform calculations on the basis of these categories. There are 3 alternatives under considerations identified as M, N, and O. The costs are summarized below. Use an annual life cycle cost approach to identify the best alternative at 8% per year. So here are alternatives M, N, and O, and these are the components of each alternative. For component M, for alternative M, we have 4 components: development, programming, operation, and support. And for component N, we also have all these 4 components. And for component O, we have only one component, that is operation. And estimated costs for each component for alternative M are: for development, for $250,000 at time 0 and $150,000 from year 1 to year 4 every year. Then in programming component, we have 45,000 now at time 0 and $35,000 in year 1 and year 2. And in operations, $50,000 every year from first year to the 10th year. And in support component, $30,000 from year 1 to year 5. And in case of alternative N, the cost of development component is $10,000 at time 0. And for programming component, $45,000 at time 0, $30,000 to years 1 to 3. And for operations, $80,000 from year 1 to year 10 every year. And in support component, $40,000 from year 1 to year 10. And in case of alternative O, we have only one component, that is operations. And the estimated cost of operations for component O is $175,000 from year 1 to year 10. Now let's compare these alternatives on the basis of life cycle cost analysis. So first of all, we need to calculate present worth of all these components. So let's start with project M. So the present worth of development component will be equal to present worth of 250,000 at time zero. This amount is already at time zero. We do not need to perform any calculation to convert it in time zero. Then 150,000 from year 1 to 4. So we have to convert this amount into present amount by using P over A factor. So because these are amounts from year 1 to 4, so we can consider these amount as annual payments. So while converting in present amount, we have to use P over A factor. So 150,000 P over A factor for 8% and 4 years. Then in case of programming component, 45,000 will be as it is because it is at time zero, and 35,000 P over A factor for 2 years and 8% rate of interest. Then for operations, 50,000 every year from 1 to 10th year. So 50,000 into P over A factor for 10 years and 8% rate of interest. Similarly, in case of support component, 30,000 every year until year 5. So 30,000 into P over A factor for 8% rate of interest and 5 years. Then the factor value for P over A factor for 8% and 4 years is 3.3121, and factor value for P over A for 8% and 2 years is 1.7833. And P over A 8% 10 years factor value is 6.7101, and P over A 8% 5 years is 3.9927. Now we have to solve this equation and to calculate final present worth of alternative M, that is minus $1.309 million. Now next we have to calculate present worth of alternative N. So we have present worth of alternative M. We can convert it into annual worth by using the formula of annual worth. That is equal to present worth into A over P factor for given rate of interest and number of years. So here we have 8% rate of interest and number of years are 10. So the factor value is 0.14903. And the annual worth of alternative M will be $195,157. Now the next thing is to calculate first present worth of alternative N and then convert it into annual worth. So let's start by calculating present worth for alternative N. So first of all, we have development component. It will come as it is because 10,000 now, this is already at time zero. So 10,000 as it is and 45,000 at time zero. It will also come as it is and 30,000 from year 1 to 3. So these are 3 annual payments. We'll use a P over A factor to convert it into present amount. P over A factor for 8% and 3 years with $30,000. Then in case of operations, 80,000 every year from first year to 10th year. So these are 10 annual payments and we need to convert it in present worth by using P over A factor for 8% and 10 years. And finally, in case of support component, 40,000 throughout 10 years. So these are also 10 annual payments. 40,000 P over A factor for 8% and 10 years. Now we need to put factor values. 10,000 as it is, 45,000 as it is, and 30,000 P over A factor for 8% and 3 years, whose value is 2.5771. Then 80,000 P over A factor for 8% and 10 years, factor value is 6.7101. And finally 40,000 for support component for 10 years. So P over A factor value for 8% and 10 years is 6.7101. The resulting amount of present worth for for alternative N is $937,525. Now, once we have the present worth, we can convert it into annual worth by using annual worth formula. That is present worth multiplied by A over P factor for given rate of interest and number of years. So the present worth is $937,525. And A over P factor for 8% and 10 years is 0.14903. In that case, the annual worth of project N will be 139,719. And with regard to project O or alternative O, we have only one component, that is operations, and cost is given in terms of annuities already. 175,000 per year from year 1 to year 10. So we do not need to perform any calculations. This is already given in annual terms. So annual worth of option O or alternative O is $175,000, and the annual worth of option M was $195,157. Now, if you remember the criteria to compare the annual worth is that in case of cost alternatives, less annual worth means less negative annual worth, and in case of revenue alternatives, highest positive annual worth. So here we have cost alternatives, so the criteria will be the less negative annual worth. So the less negative annual worth is of project or option N in that case. So we'll accept alternative N and we'll reject other two alternatives M and O. I hope this is clear for everyone how to perform life cycle cost analysis as well. So I will wait for you to go through the topics and come up with your queries, and we'll discuss them within interactive session, inshallah. So stay safe. See you soon, inshallah, again with the next video. Take care. Allah Hafiz.